Good afternoon, my dear student. Today we will repeat the experiment number 2, verification of maximum power transfer theorem. Because most of the students have confusion regarding this experiment, especially the graph corresponding to load power versus load resistance, and also one confusion between two factors. One is power absorption or load power, and efficiency, power transfer efficiency. So I will explain these two factors in details. Everyone first use the given link you see in chat box I have provided. Use the link and visit to virtual lab site of IIT KGP, and then you follow the instruction. After that you read the procedure for this experiment and make connection according to the instruction given in the slide. Okay, in the present slide everyone see that there is a circuit diagram and also some instruction are given in the same slide. You first connect the circuit, and initially at first everyone the value of inductance and capacitance, otherwise you will get a logical error, that is NaN. So to avoid the logical error, everyone first select the inductance and capacitance values, then you switch on and see the readings, load power and efficiency. After that you bypass the inductance and capacitance values from source side as well as load side. Okay, so everyone first connect the circuit, then choose the proper values of inductance, capacitance and resistance. After that bypass the inductance and capacitance side. Okay, and you repeat this experiment for at least 15 to 20 number of resistance values. Okay, so let me explain the two things, load power and power transfer efficiency. There is a confusion between these two factors. Everyone see the curve corresponding to load power versus load resistance is a bell-shaped curve. You see here. Okay, but on the other hand, the curve corresponding to efficiency, power transfer efficiency versus load resistance is an exponential curve. So you will get two different types of curve. One is bell-shaped curve, that is the variation of load power versus load resistance, and another one is, and you see the variation of load power versus load resistance. This curve attains a maximum value at source resistance equal to load resistance. You see the point this point is indicated by an arrow, and you see here RL equal to RTH. RTH is nothing but the Thevenin equivalent resistance of the circuit, that is the input resistance or internal resistance of the circuit, and this is the load resistance. At this point where load resistance equal to internal resistance or source resistance of the circuit, at this point you will get maximum power, and at this point the efficiency is 50%. Now let me show you the curve corresponding to power transfer efficiency versus load resistance. Power transfer efficiency versus load resistance. Okay, don't make any confusion between these two curves. Okay, one is load power versus load resistance, and another one is power transfer efficiency versus load resistance. Okay, so you see load power becomes maximum at RL equal to RS, source resistance, and on the both side of this point load power decreases. Okay, load power becomes maximum at a point where RL equal to RS, load resistance equal to source resistance, and both side of this point load resistance decreases. Okay, so that's why you will get a bell-shaped curve. But if you see the variation of power transfer efficiency versus load resistance, you will see this is an exponential curve, and this exponential curve, power transfer efficiency become 1 when load resistance tends to infinite. You see the calculation part here. You know efficiency is nothing but the ratio of load power versus total power of the circuit. Total power transmitted by the source resistance is power transmitted by the source, and power absorbed by load or consumed by load. So you see total transmitted power equal to PL, load power plus source power. So I square into RL plus I square into RS, where RL is the load resistance and RS is the source resistance, and I is the current in the circuit. And you know efficiency is the ratio of load power and total transmitted power. If you put the values of load power and source power in this equation, then you finally will obtain 1 by 1 plus RS by RL. Therefore power transfer efficiency is equal to 1 by 1 plus RS by RL, source resistance divided by load resistance. If we consider load resistance tends to infinity, if RL tends to infinity, then it equal to 1, because this part becomes 0. The denominator part has two terms, 1 and RS by RL. If RL is equal to infinite, then this term is negligible. So you can write eta equal to 1 by 1. Eta equal to 1 by 1. So therefore you must try to understand the difference between power transfer efficiency and load power. Load power is maximum at a point where RL equal to RS, where load resistance equal to source resistance, but on the both side of this point where RS equal to RL, load power actually decreases. Okay, but on the other hand you see power transfer efficiency eta increases with load resistance. Eta increases with load resistance, but load power actually attains a maximum value for a particular condition when RL equal to RS, but otherwise it values actually lesser than that maximum value. But power transfer efficiency increases with load resistance. So everyone, okay, everyone don't make a confusion between power transfer efficiency and load power. the fundamental difference between these two things is load power is maximum for a particular condition when RL equal to RL, but power transfer efficiency is increasing with increase of RL, load resistance. Okay, and why load resistance equal to means infinite? Because you see 1 by 1 plus RS by RL, power transfer efficiency, and you see this curve does not reach or meet to 1, because RL, if when RL tends to when RL equal to infinite, then eta will be equal to 1. That's why there is a space between 1, this line indicates 1, and this curve. Okay, because when RL equal to infinite, then eta will become 1. Okay, now let me share the result. Okay, only one student have completed this lab, and she also submitted the lab report. Only one student. Okay, so I will share her readings with all of you. Everyone see. Only one student among you has completed this experiment, and she also submitted the lab report. Let me share her her result with you, with all of you. Okay, everyone see. Everyone please take reading at least 15 to 12 values, 15 to 20 set of load resistance. You consider at least 15 to 20 different values of load resistance. Okay, now everyone see the present slide where I have given the readings or result of one student who has submitted her result. You see here, she took load resistance value. She actually considered load resistance value 85, started 85, then 86, 87, up to 100, 112, and she note down the corresponding load power. So you can note down the load power from the virtual lab experiment setup. You will see there at the bottom of the circuit diagram there is a section from where you can note down or you can get the values of load resistance, values of load power and efficiency for different values of load resistance. So you see at 100 ohm resistance, when load resistance equal to 100 ohm, then load power becomes maximum. The maximum load power she obtained for 100 ohms when RL equal to, because she considered source resistance equal to 100 ohms. Okay, so I suggest everyone don't consider this setup. You consider source resistance 110 ohms or other values instead of 100 ohms. Everyone listen to me carefully. You consider source resistance 110 ohms or 120 ohms. Don't consider load resistance equal to 100 ohms. Okay, and then you change the load resistance values from suppose 95 to 95. If you consider source resistance 110 ohm, then you consider load resistance 95 to 120 or 90 to 120. Okay, so 90 to 120, that 120, that means you will get total 20 readings. 90 to 100, 110, that means 30 readings. You will get 30 readings. So then you can start from 95. 95. So you, everyone, first choose a proper value of source resistance, maybe 110 ohms or 120 ohms or 90 ohms, whatever. After that you change the load resistance values by considering the source resistance values as the middle value. Okay, so you change the load resistance value on the both side of this 110 ohms or 120 ohms, and you take at least 20 number of readings. You take at least 15 to 20 number of readings. Okay, after that you draw the graph, load power versus load resistance, and also efficiency, power transfer efficiency versus load resistance. So you will get two curves, one for load power versus load resistance and another one for load power transfer efficiency versus load resistance. Okay, so let me show you the curve which one the student got through this experiment. Okay, I will not repeat this experiment. Okay, this is the last this is the last day. Okay, today is the last. Okay, I will not repeat this experiment. So if anyone has any doubt or any confusion regarding this experiment about the theory part or practical, if you face any problem to perform this practical, you please write in your chat box about your confusion. Okay, if anyone has any doubt or any confusion to perform this experiment, please let me know, or you write down in your chat box. Okay, everyone, see the present slide where I have given the graph corresponding to load power versus load resistance. Who is one? The student, only one student who completed this experiment. Okay, has submitted this graph. Okay, so you see the graph, along the y-axis is the load power, along the y-axis is the load power, and along the x-axis is load resistance. And this the main I think the main problem you can face to draw this graph using load power, different values of load power and load resistance, that is the unit, that is the value of small unit, that is the value of small unit. So you must select the proper values of small unit along the x-axis and also along the y-axis. Otherwise your graph or your curve may be different from the correct graph or from the appropriate graph. So everyone, after getting the readings, I mean load power and different values of load resistances and corresponding load power and load efficiency, you must select the unit, small unit along the x-axis, value of small unit along the x-axis and also along the y-axis according to your readings, Okay, so for this case you see that this student has considered the small value of small unit along the x-axis is 0.02 ohm. On the other hand, the value of small unit along the y-axis is 0.01 microwatt. 0.01 microwatt. These 2 points are very important to draw the graph corresponding to load power versus load resistance. Load power versus load resistance. So after getting the readings, at least 15 or 20 readings, you choose the value of small unit for x-axis and also for y-axis based on the values of load power and load resistance. Okay, for this case the student has considered the value of small unit along the x-axis is 0.2 ohm and along the y-axis is 0.01 microwatt. Okay, so I suggest all of you at least you take at least 15 to 20 readings for load power and load resistance. After that you choose the value of small unit for x-axis and also for y-axis. Okay, and finally you draw the graph. Okay, if anyone has any doubt or confusion to perform this experiment, please let me know, or you write down in the chat box. You write your confusion in the chat box. Okay, one thing everyone remember it, that efficiency increases with increasing of load resistance. Power transfer efficiency increases with increasing of load resistance. On the other hand, load power initially increases after getting a maximum value it decreases. Okay, load power initially increases with load resistance, but after getting a maximum value where RL equal to RS, the load power decreases. Load power decrease. This is the difference between power transfer efficiency and load power. Don't make them actually as the same factor. Okay, these are two different factors. Don't consider these two factors as a same parameter. Power transfer efficiency and load power. Power transfer efficiency and load power are two different terms, are two different factors. The maximum value of power transfer efficiency is 1, but the maximum value of power is not 1. Okay, now let me tell you one important thing. I have seen that most of the student, maximum student actually highlighted or just copy the whole things from virtual lab site and paste in their lab report. I have seen that most of students just copy the whole things from the virtual lab site and paste in their lab report. I suggest all of you don't do this. Don't copy A to Z from the virtual lab site and paste in your lab report. Don't do it. You write your lab report in a compact form. You write your lab report in a compact form and you try to write your lab report in your own language. In your own language, don't copy from other site or virtual lab site. Okay, so you mention in your lab report at first the date of the experiment, after that name of the experiment, then require components, after that theory part. In theory part you write theory part in brief. No need to discuss theory part elaborately. Don't discuss theory part in detail. You just discuss theory part in brief. Okay. After that you write the procedure, I mean the steps involved to perform this experiment, step involved in executing this experiment along with circuit diagram. After that you write result section. In result section you highlight the table, observation table and the graphs. For today's experiment you attach two graphs. You highlight two graphs, one for load power versus load resistance and another one for power transfer efficiency versus load resistance, and finally you write your conclusion. So therefore in your lab report for each experiment there will be total how many sections? First is name of the experiment, apparatus, component, required component, theory part, procedure, I mean method, result and conclusion. Total 6 sections. In your lab report you write total 6 sections. One is name of the experiment, then component, required components, after that theory part in brief, then procedure or methodology, then result section and finally conclusion. Okay, and one thing you must mention the date of the experiment, okay. So if anyone copy everything, Sayan Vishal, no need to submit experiment 1 and experiment 1. Okay, but you don't repeat this thing for experiment 2 and experiment 3. Sayan, no need to submit experiment 1, but you don't repeat this thing for experiment 2 and experiment 3. Don't copy everything from virtual lab site and paste in your lab report. Okay, you write your lab report in a compact form, I mean in your own language. You write theory part in brief, you write result section by arts. We already submitted experiment. Okay, Artsraj, who have already submitted experiment 3, no need to submit it again. Okay, but remaining all don't repeat the same thing. No sir, I am in case of experiment 1 I submitted in comment section. Sion, I cannot get your point. I am in case of experiment I submitted in comment section. So should I submit yes, Sion, you can submit the experiment 1 in assignment section. Okay, no problem. Otherwise you can leave it, no problem. If you want to submit experiment 1 in assignment section you can submit it, but if you want to, if you don't want to submit it again you leave it, no problem. Okay, but I am telling you that don't write your lab report, don't write your lab report just by just copying the whole things from virtual lab site and paste your lab report. This is not a lab report. Okay, you write your lab report in a compact form and in your own language. Okay, that who will submit lab report in a compact form and who will write lab report in his or her own language, he or she will get good marks compared to others who will copy everything from virtual lab site and submit. I will give less mark. Okay, Harshana, no need to submit experiment 1 and 3 because you have already done. If you want to submit, I have no problem, you can submit it, but if you want that whatever you have submitted that is okay, then no need to submit it again. I will consider initial submission. I will consider your initial submission for experiment 1 and experiment 3, but don't repeat same thing whatever you have done for experiment 1 and experiment 3. Okay, so I suggest all of you write your lab report. It is not compulsory. Yes, it is not compulsory, but from today's experiment, from experiment maximum power transfer, from today's experiment onwards, everyone write your lab report in a compact form and submit it. Okay, don't copy and don't copy everything from the virtual lab site and paste in your lab report. Don't do it. Okay, so from today's lab experiment, you write your lab report in a compact form and you try to write your lab report in your own language and you submit it, then you will get good marks. Okay, thank you everyone. Now this is the actually this experiment maximum power transfer theorem experiment we have done before today. This is the today we repeat this thing. Okay, because of your doubt, if you have any doubt or confusion or any difficulty to perform this experiment or about the theory part, you can write in your chat box or please let me know, because we will not repeat this experiment after today. So everyone try to understand the experiment in details, try to understand it. Okay, and don't make any confusion between two important terms. One is power transfer efficiency and another one is load power, the power delivered to load. Okay, so everyone take at least 15 to 20 readings, and you must mention your you must mention the readings in your observation table and highlight that observation table in your lab report. Don't copy from others, don't use same readings. You use your reading, don't use other readings in your lab report. Everyone perform this experiment by considering different values of load resistance and source resistance. Everyone first consider a particular value of source resistance and keep it fixed throughout the experiment, and you take at least 15 to 20 readings for load power for corresponding to different values of load resistance. I suggest everyone repeat this experiment. Repeat the experiment for at least 15 to 20 values of load resistance and note down the corresponding load power and efficiency. Don't copy other readings. Don't highlight other readings in your lab report. If anyone faces any difficulty to perform this lab experiment, please let me know. Don't use other lab readings. You use your lab readings. You do experiment yourself. You perform, you execute this experiment yourself and note down the readings and include those readings in your lab report. Okay. The maximum power transfer theorem is an important theorem. For communication as well as power transmission in the both field, power transmission and also communication. We always want a system which can provide maximum power to its load side. We always want such a system which can supply maximum power to its load. Okay, in our real time system, we always prefer a system which can provide maximum power from its source side to its load side. So we need to understand this theorem in details, because in future if you want to design circuit for communication purpose or power transfer purpose, in the field of satellite communication, in the field of radio wave communication, in the field of mobile communication or radar or even VLSI, everywhere you will see the application of maximum power transfer theorem. So I suggest everyone, please try to understand this theorem in details. Okay. And if you have any difficulty or confusion regarding this theorem or today's experiment, please write in your chat box or please let me know. Okay, I hope everyone understand the procedure or step involved in this experiment and why maximum value of efficiency is equal to 1 and for load power is not equal to 1. Okay, the reason behind this I hope everyone understand. And another thing, for practical application we always consider load resistance greater than source resistance to avoid the circuit damage due to heating effect, to avoid damage of the circuit due to heating effect. You know, the maximum power transfer condition happen when load resistance equal to source resistance, but for practical case we have noticed that for maximum power transfer condition there is a heating effect in our system, in a particular system or given system, and as a result the system get damaged or burned out due to heating effect. To avoid damage due to heating effect, we always consider load resistance greater than source resistance. Okay, and sometimes we need such a system where efficiency is important compared to power. You have realized that efficiency is 50% when maximum power transfer condition takes place, but sometimes we need such a system for which efficiency should be greater than 50%, especially power transfer circuit case. For the case of power transform, that time we will consider efficiency greater than 50%, at least more than 60%, and that time we also consider load resistance is greater than source resistance. The value of load resistance is greater than source resistance. Okay, so I hope everyone understood the concept or theory behind the today's lab experiment. Okay, so thank you everyone, and you must submit your lab report for today's experiment within the deadline, and in a compact form highlight the observation table along with two curves, one for load power versus load resistance and another one for power transfer efficiency versus load resistance. Okay everyone, let me stop. And everyone please write your ID and name in chat box. Everyone write your name and ID in your chat box. In your chat box you write your ID number. After executing this experiment, everyone must submit your lab report within the deadline, and you submit your lab report in a compact form. Don't copy everything from the virtual lab site or other source and paste in your lab report. Don't do it. You write your lab report in your own language. Okay, in your own language, and you mention the observation table and two curves I mean in your lab report. Okay, so you complete it first. Everyone complete it and use the readings whatever you got through your experiment. Don't use other readings. Okay, I suggest everyone perform this experiment and use the readings whatever you will get through this experiment in your lab report.